Sci Access, May 11, 2024. Making connections to the National Research Agenda for STEM education for students with visual impairments by creating a biochemistry lab access video series. Karbowski, Emril Bennett.
Hello, everyone. My name is Karbowski. My pronouns are she, her, and I am a white woman with shoulder-length brown hair.
My name is Emril Bennett. I'm a young woman with very short brown hair and brown eyes, and my pronouns are she, her.
Our presentation is making connections to the National Research Agenda for STEM education for students with visual impairments by creating a biochemistry lab access video series. Back at 2019 Sci Access, which was in person, I remember leaving the conference feeling like I'd learned such great new ideas, and so I was sharing it with all my friends, but I was doing this individually. I wish there was a way that people who weren't at the conference were able to hear about all the accessible techniques that I had learned. So I was trying to think of a way where I could do that, and I thought I should probably do something on YouTube with links that I can share virtually so the public can see that. So I started building upon this idea, and then at 2019, I went to the Island Conference on Disability and STEM, and there was a presentation by Tom Grushka and Dr. April Hill where they were showing good and bad ways to work with blind and low vision scientists in a chemistry setting. And then I saw videos from Kate Frazier, retired science teacher at the Perkins School for the Blind, where she was demoing some accessible techniques. With these videos, though, none of them were showcasing the lab techniques that I had used in a biochemistry research lab at The Ohio State University. We did a lot of gel electrophoresis, protein purification, and I wanted to find people who were doing those skills and share those. I saw an article by Kuhn and others in 2022 about 3D printing grayscale photographs of lab results, including the gels from electrophoresis, which is what I did, and I wanted to be able to showcase that for a large audience. Then in 2022, Dr. Wild and other researchers published the National Research Agenda for STEM education for students with visual impairments. And in this agenda, they list 12 goals to foster more inclusion in STEM. And then by seeing these goals, I was better able to refine the project idea so that way we could have more impact. Emril and I worked together on this video series where we demonstrate biochemistry lab techniques that we did in the research lab that I worked in, and then we use these goals to make our project better by addressing more aspects than just sharing techniques and videos. And I'm going to share how those goals apply to our project. So the first goal is collaboration in the agenda. And we did this by working with blind and sighted scientists to come up with accessible techniques. And then blind and sighted content creators, Emril and I worked on making the videos. So I'm a sighted biochemist, and Emril is blind and interested in doing STEM. We worked on Goal 3, Skills to Succeed in STEM Education, and Goal 9, Transition and Mentorship, by having an experience for Emril to learn the accessible lab techniques and an experience for me to learn from Emril how to best teach the skills and find a way to work collaboratively in the lab. And we achieved Goal 8, Identity, and Goal 11, Personnel Preparation, by exploring our identities through social media, posting on different platforms. We both had personal YouTube channels that we then combined together in a playlist for our videos. And we worked with personnel preparation by having a selection of our videos on the Perkins Accessible Science page, which many teachers of blind and low vision students go to get resources. We worked with Goal 10, Technology Exploration, by using the Talking Lab Quest 2. It's a device that you can connect vernier sensors to, and it reads out the data and also records it on the device. After looking at the agenda and realizing that we wanted to do more with technology exploration, we decided to highlight how we were using Braille display an iPhone and Mac computer with VoiceOver to edit our videos. And beforehand, we were just focusing on accessibility for lab equipment and less on the accessibility of video software. But we decided to do more of that once we saw the agenda. And we also worked with Goal 12 advocacy by talking with science supply companies such as Biorad and Empedorf on ways to improve their lab equipment, as well as receive donations to use in our videos. And we did a lot of advocacy on social media by posting these videos. We also have a photo of Emril reading on the Mantis Braille display, which we trialed out using in the lab by placing it on absorbent pads so any chemicals would not get on the device.
We used these concepts to create a series on YouTube and observed viewer behavior in order to find strategies to best promote this kind of content.
So an overview of our project. So we started out with a proof of concept. I made a video during COVID where I was using the Talking Lab Quest 2 to record the temperature of aquarium tanks. And then I worked with my friend to do a video showcasing wheelchair accessibility. I then submitted these videos in my grant application to receive more funding, which I then worked with Emril to make more videos, including run through of strategies and experiment and practicing demos. We talk about measuring liquids, labeling supplies, wearing goggles with prescription lenses, doing an acid-base titration, and doing gel electrophoresis. In these long-form videos, we then took segments out to make YouTube shorts, and then we also posted a lot of these videos on the Perkins Accessible Science page. And here's a photo of me using the temperature probe to measure the aquarium tanks in our first video.
So, as mentioned before, I co-created these videos with my friend and mentor, Caroline. Together, we developed collaboration strategies so us as a small team of both blind and sighted creators could work together inclusively and effectively. One strategy we tried was using short keywords to indicate the start and end of filming, as well as when to make cuts when editing film. We found this strategy effective for our specific needs. We chose Apple's iMovie as our editing software of choice because it was one of the few options available we knew of that was somewhat screen reader friendly. I used iMovie's available keyboard shortcuts on our lab's Mac to edit the film while listening to audio cues within the video, as well as Caroline's visual descriptions. Since this is an accessibility-focused playlist, we wanted to engage as many people as possible and make these videos as accessible as we could. So we did some work to improve the video captioning. First, we fixed translation errors and, other mistakes often found within YouTube's automatic captions. And where we felt it was necessary, we typed captions manually, thus overriding the automatic captioning altogether. Additionally, we embedded descriptions in some of our captions. These are just some of the strategies we used that could be implemented in content creation, and we encourage others to use our work as a starting point to then find and or create strategies that work for them and to further improve the accessibility of content creation.
So we're going to give some highlights from some of the videos we did and share strategies. So in our measuring volumes of liquids video, we talk about feeling the water level with a finger in bump dots inside a graduated cylinder. And there's a photo of me doing that at the lab, the water pump. We used a 2-stage liquid level indicator to indicate the levels of water at a lower and then a higher point. And then we also drew black lines on glassware. I have a photo of a volumetric flask, and then we used a Sharpie to draw a line at the fill line to make it more visible. And you can also use a barrette reading card behind your flask to better see the meniscus. We also use pipette pumps with calibrated laser-cut rectangular inserts that I made at The Ohio State University's Makerspace. These are little rectangles that are different lengths that were pre-calibrated. And then we also use Biorad's fixed volume micropipettes. These are at set volumes that always can stay the same, so you put labels on them and then can measure out that way. And we also used a notched syringe that again was pre-calibrated at certain volumes. In biochemistry at my lab, we used a lot of pipettes that are adjustable. So I found that the Fisher brand Elite adjustable volume pipettes had the largest readout. It was the large enough screen to read on, and it had tactile feedback when turning the dial, so you could count some of the clicks, and some even have locks. However, though, if you really need something that doesn't need as much support from a sighted lab mate, you can use those fixed volume pipettes. Then we also use the OHA Scout scale with the Talking LabQuest to measure the mass of water and then use density to calculate the volume. And we tested a lot of these different methods with density to see how consistent they were. In our labeling lab supplies video, we used clear braille labels such as Dymo tape and brailleable labels with a slate and stylus. I have a photo of us using the slate and the labels on a Falcon tube. We use pre-made large print braille labels such as the touch to see labels that have the alphabet and numbers on them. We used hair ties on Falcon tubes with different plastic decals that you can quickly feel. And we also tried out the Pen Friend audio labeling system. This device, when you tap it onto a sticker, the sticker vibrates, or the sticker is specific. And so when you tap it with the Pen Friend, you can record that specific audio. But the problem we had is it would sometimes fall off in water. In our titration video, we used the Vernier drop counter to count how many drops of base went into our cup of acid. We used the titration color cam app on a bendy tripod on an Android phone to know when the end point of the titration happened. So when the liquid in our flask turned pink due to the phenylalanine at the end point, the app recognizes that and would vibrate and make noise. And there's lots of different indicators you can select on the app. And then we used the Talking LabQuest to give us audio readout for our volumes. And it also would measure pH, and it also could give us a sonification of our sigmoidal curve in our graph and give us statistics. In our electrophoresis video, we did protein gel electrophoresis because that's what we did in my lab. We put braille labels on the fixed volume micropipettes to get 5 microliters. And since our Pen Friend labels didn't work, we tried out using braille laundry tags with numbers on them. These are little metal tags that also have large print. We connected them with an electrical tie to a microcentrifuge tube, so that way it would not disintegrate in water. And this was pretty effective. And then to load the gel in each specific well with the pipette, we used a loading guide that Biorad already made. I just found it in the drawer at my lab. And then that way you can feel the slots and know where to put your tips so your sample goes in the right spot in your gel. And then to see the results of the gel, we 3D printed it by taking a photo of the real gel, converting it to grayscale, and then printing it out. On the power supply for the electrophoresis setup, we put braille labels. And then to put our electrophoresis chamber together and get it ready in the power supply, we put bump dots on all of the positive ends. So that's what is red. So on our lid, on the chamber, on the outlets, everything had a bump dot so you could line it up. Also, so we're now on our analytics page because we wanted to look at how YouTube did over time. And what we saw was I have a photo here showing gel electrophoresis parts 1 through 4. It's a screenshot from YouTube. It had 130 views. It was a long video. Then we did a short video, had 2,600 views. It was a segment from the electrophoresis, and it was called Wedged Power Supply Plug.
According to YouTube, a short is any video that shows up in their specially designed player. Videos cannot exceed 1 minute in length. For our purposes, any video that exceeds the 1 minute shorts limit is categorized as long-form content. We had 7 shorts and 12 long-form videos. For shorts, our average number of views stood at 691, and our average long-form video would get 70 views. We wanted to know what kinds of videos our audience was interested in, so we categorized them and took their average number of views for each category. Our category with the highest average view count was DNA gel electrophoresis, followed by lab safety. Our active months with the highest view counts were March and April of 2023. Since shorts were getting more views, we decided to clip moments from our long-form videos and that we'd already made and reposted them as their own shorts to further spread the message. Here are some strategies that we had learned during this process. We recommend these strategies for other creators who want to produce this kind of content. So firstly, research into the platforms that you want to use so you can pick the one that best suits your particular needs. If you personally use social media or video creation platforms, look at your home feed to gather clues on what kinds of content are trending. This can help you to stand out and attract an audience, as well as avoid problems caused by under or oversaturation of content. Read titles, read articles about, and follow influencers who produce tutorials on how to use your specific platform. They may also provide tips on what is useful and what to avoid. Create content based on the information you've gathered. For example, if you see that less shorts are appearing on your feed or that your shorts are getting lower view counts than they normally would, then that could be an indicator that shorts are currently on the decline, and thus more long-form content would be of benefit. So, after you're done creating a piece of content, note the time of day, morning, afternoon, evening, or night that the content was posted. Keep track of the view counts of these, as this can help you know when it's the optimal time to schedule your posts. Keep track of relevant or trending title keywords and or hashtags that are specifically related to your content. Certain keywords may tell the platform that you're using what kinds of audiences would enjoy that content, so making sure you use appropriate keywords is key in spreading your message. So our next steps. Our combined work at Emril and their associated partners work to increase disability awareness through our content. We are looking to further our advocacy by increasing the range of content topics that we're providing. We encourage other content creators to build upon what we've created. We feel that a diverse range of content creators could help spread the message regarding science accessibility and furthermore accessibility and disability awareness as a whole.
And it'll also be putting our YouTube playlist in the chat or on the forum. We wanted to disclose some of the financial involvements involved in this. So Independent Science did give us a discount on the LabQuest in exchange for using it in videos, and BioRad did donate the micropipettes in exchange for using in videos. We also received $3,000 from the Ohio State Honors and Scholars Enrichment Grant to make the videos. All of our reviews are unbiased and of our own opinions. There were no paid promotions to say anything. The purpose of the videos was to share accessible lab techniques. We also would like to acknowledge the Ohio State University Departments of Evolution, Ecology, and Organismal Biology, the Department of Chemistry and Biochemistry, and Biological Chemistry and Pharmacology, specifically Kevin Loomy, Barb Shardy, Dr. Nicole Karn, Dr. Charles Bell, and Kate Zakharova, who are the scientists who helped us gave us lab space and supplies to use. Thank you to Charlotte Cushman for writing the pages for the Perkins Accessible Science page, our filming team, which was Jackson Burkholder, Michael Smith, and Caden Gill, and our blind scientist consulting team, comprised of Ashley Neighbor, Dr. Kelly Supalo, Dr. Mahadio Sukai, and Dr. Mona Mankara. We really appreciate everyone who helped us make this project a success, and I encourage you to check out our channel and leave any comments and feedback so we know what we can do for future endeavors. Thank you.
Oh, and I apologize about what happened earlier. Oh, no.
You're good.
Emril, Caroline, that was fantastic. Thank you
Thank
so
you.
much for your talk. We do have a few questions for you here.
Oh dear. And I want to preface by saying I'm sorry about that beeping. My stupid weather, it's storming where I'm at, and it decided to run. It decided to go.
You're perfect. Yeah, all is well. And we've got a few folks having questions here in the chat. The first is from Sarah, who says, have you guys thought of doing any content for biochemistry related to microscopy? Wow, I can't say that word.
Oh, microscopy.
No,
microscopy, thank you.
No, we've not done that yet.
No, I will say, like, one thing I have done is using IRA, the visual interpreter, with a microscope, so you can video call someone to give live feedback. I've also seen using a large monitor with a microscope, or connecting your microscope with the camera to a tactile graphics display. I would love to see more with cryo-EM. A lot of the microscopes are controlled by computers and are very database now, so there's a lot of opportunity for accessibility there.
Yes. I just don't think that's an area that's been tapped into as much as it should, really.
Fantastic. Alberto asks, have any of the videos been published on TikTok or other platforms, or perhaps remixed?
Like I said, we've put them into shorts. I'm not a TikTok user personally. I find that platform to be a little toxic. But we have put them into shorts ourselves, and those have been doing all right. So, but we could consider, if Caroline's okay, having her do that stuff, because I'm trying to avoid that whole mess, really.
Awesome. I also just want to mention a lot of great comments here in the chat of Lisette saying that she'd love to share your work through her center. And Sarah saying, love the different cool 3D printing ideas here. So lots of exciting comments here in the chat.
Yeah, it definitely have C3D as a partner brand. So
absolutely. And one final question here. As part of my disability, I'm not only blind, but have an additional cognitive impairment. Can you accommodate me?
Oh, I think, Emril, let's hear it. Let's hear you.
I don't know about in the current state, but we will look into it.
And I think a lot of it too is talking with you about your needs and finding out what we can do to make it accessible. I really think anything can be done. It just requires a conversation and some imagination and creativity.
Fantastic.
And even a couple creatives.
Sci Access. Learn more at www.sciaccess.org.